Hello everyone, today is day 29 of Python Pro from CTC. We are going to dive into sorting algorithms again. Insertion sort. Insertion sort is a simple algorithm. Basically, it follows an incremental approach. We are going to iterate through all the items in the array in insertion sort. Then we will compare it with the previously sorted array. That is, you will get when you are going through this. So, here we have got 9, right? We have to compare 9 with the previous elements, that is the elements before it, and have no elements before the element itself, so we don't have to compare it with anything. So then come to the next element. So basically the insertion sort starts with the second element of the array, that is from index 1. So we are going to compare 7 with its previous element, that is 9. So we are going to compare these two. Obviously 7 is lesser than 9, so we will just insert 7 before 9. Then we will come to the next element 5, and we will search for the perfect spot for 5. So now this place is sorted array, right? This place is sorted array. We are going to extend the sorted array through the iterations. So here we have got 5. We will search within the previous sorted array, and we have got to know that 5 is even lesser than 7, so we will insert 5 before 7. Same goes for 3, cause 3 is lesser than 5. Let's say we have got a 6 here. We will check with the previous array, and we can just insert the 6 between the 5 and 7. Similarly, we have got 1, and we will insert 1 before 3. We have got a sorted array now. This is basically insertion sort. This is the Python implementation of insertion sort. Here we have got a function called insertion sort where we are passing the array itself. Now we are storing the length of the array in the variable called n. Then for I in range of 1 comma n, that is we are iterating from the second element of the array till the end of the array. We are storing the current element, that is array of I, as key, and j as I minus 1, that is the previous elements, that is the elements before ith index. So while j is greater than or equal to 0, that is we are using these conditions so that the loop will never go out of bounds. And if the key is lesser than the array of j, the key should be lesser than the array of j so that we can swap it. If not, we can just go on with it. So if key is lesser than array of j, we will just swap the elements. Array of j plus 1 is equal to array of j. That is, we are going to make every element before the current element to switch one place to the right, so that we can insert it in the blank space we will get. That is, if we are going to insert, let's say we are going to compare 11 with 12. 11 should go here, right? Before that 12 should come here. So array of j plus 1 equal to array of j, so that this 12 will come this side. Then array of j plus 1 equal to key. Through every iteration we might get 2 or 3 elements before the current element, right? So we will be iterating with the while loop till the element is in the right place. If the element is in the right place, we will just swap it to the key. Then we can I'm just using this print statement so that we can know what are the steps actually happening here with every iteration. So let me just delete this out, and yeah, as you can see, 11 and 12 already sorted, 11, 12 and 13 already sorted, 11, 12, 13 and 5 should come here, 5 came here, 11, 5, 11, 12, 13 and 6 should come in between 5 and 11, it came here. So this is what basically how insertion sort works. Now selection sort. Imagine you are selecting the smallest item from the unsorted pile and placing it at the beginning. Selection sort follows a similar principle. It repeatedly selects the smallest element from the unsorted portion and swaps it with the first unsorted element. See how this actually works with the help of an example. So we will take first element as the minimum index. and we will compare it with the smallest element. We will take the smallest element in the array. So smallest element is 1. So we will swap both of them. Now 1 is sorted, right? Now this portion, the first element is sorted, but these aren't sorted. So next we will again take the smallest element of the unsorted portion, that is from 5 to 4 we will take the smallest element, that is 2, and swap it with the first unsorted element. What is the first unsorted element here? 5. So we will swap them again. Now till 2 they are sorted, from 7 to 4 they aren't sorted. So we will take the smallest element, that is 3 here, and swap it with the first unsorted element, that is 7. Again, what we are going to do, from 7 to 4, again these aren't sorted. So again the smallest element is 4, will get swapped with 7. Now 4 and 5 are in right place. Now we'll take 6, the smallest element, and compare it with the unsorted element, first unsorted element, and swap them. 8 and 6 will get swapped, and again in a similar way 7 and 8 will get swapped. Thus we have got ourselves a sorted array. Python implementation of selection sort. So we'll just iterate through all the elements in the given array. So the minimum index is the current element in the first time. What we can do then is, from the minimum index element till the rest of the array, we will check for the least element, and then what we can do, we will just swap it. Every time we encounter a smaller element, we will assign it as minimum index. So what we can do is, we will just swap that the smallest element with the minimum index element, and we will do it again and again and again till we get this sorted array. Let's see the output for this array. So yeah, we have got 11, 12, then 22, 25, then 64. This is how basically selection sort works.